Sige. Alright. So, our topic is introduction to DC machines. I know that you have already a background about what are DC machines, even AC machines, no? Because you have also a subject in AC machines. So, this one is the bird's eye view, no, of the classification of motors. This one is for electric motors. As we all know, DC machines consist of DC motors and DC generators. I would like to emphasize that uh, there are two main classifications of electric motors. We have the alternating current motors or AC motors and the direct current uh, DC motors. Basically, the main difference is that the alternating current motors uses alternating current supply, of course, and the direct current motors uses DC supply. All right. So under the AC motors, you have synchronous and induction motors. The most common use in the industry are the induction type of AC motors. Under the induction AC motor, we have single phase and three phase. I know that you are familiar with this also. But our subject will focus on the direct current motors. We have the separately excited. When you say separately excited, uh, the armature has a different supply from the stator. No? That's why it's called separately excited. Uh, they have different supply. While the self-excited DC motor, we have series, shunt, and compound. Okay, so I know you have already an idea of what is series and shunt motor, and of course the compound DC motor is a combination of series and shunt field binding, right? So that's the DC motor. Okay, so what are the recurrent machines? No, so the recurrent machines are divided into again DC generators and DC motors. Actually, transformers, AC transformers or DC transformers are also DC machine, are also called machines. But in the context of our subject, so we'll just focus um, DC motors and DC generators as part of DC machines. Accordingly, most DC machines are similar to AC machines. No? They have AC voltage and current within them. Okay? So DC machines have DC outputs just because they have a mechanism converting AC voltages to DC voltages at their terminals. All right. So again, we know already the difference between AC and DC with regard to the supply. Ano again ang basic na difference because you cannot use AC supply to DC machines or DC motors or DC generator. Uh, but the generator, of course, dili na nimo supplyan class ha, ako lang i-clarify. So, by the way, if you have some questions, clarifications class, you can ask, you can interact me so that ma-address na rin ako ang mga questions niyo or clarifications. Okay? Um, Again, DC machines or DC motors uses DC supply, while AC motors uses AC supply. But the generators class now, regardless of AC or DC generator, so dili na to na supplyan, it's because ang generator is from mechanical energy to electrical energy man siya. So kailangan siya og kanang um, prime mover mag-drive sa generator para kuan siya makapagawas maka-generate siya og kuryente. Unlike sa AC machine, uh, DC machine, uh, kailangan siya og supply, or DC machine, DC motors rather, kailangan siya og supply para siya mag-operate. Okay? Questions so far, class? Clarifications? Okay ra? Masad na
Okay
ha?
ra, sir.
DC generators are not as common as they used to be because direct current, when required, is mainly produced by electronic rectifiers. Okay? Sa mga DC class generators, kailangan din siya o mga electronic rectifiers po para by the way, what is rectifier? Muna siya ang mag-convert sa AC into DC. Rectify, from the word rectify niya from alternating current to direct current. So while DC motors are widely used, such automobile, aircraft, and portable electronics, and in speed control applications. Okay, so now let's proceed to DC generator. Again, a DC generator is a machine that converts mechanical energy into electrical energy. So take note of that. Since our subject is DC machine supposedly, dili DC motor. So, ang produce sa DC generator is of course DC voltage and current. Of course, by using the principle of magnetic induction. All right. So as you can see in the illustration, that is it shows the principles of magnetic induction in DC machine. Okay, so basic illustrations DC machine principle. So in this example, the ends of the wire loop rather have been connected to two slip rings, no, mounted on the shaft, while brushes are used to carry the current from the loop to the outside of the circuit. Okay. So any questions, class? Clarifications? Actually, slip rings, kani siya ang gigamit diri, di ba? Last meeting I've discussed about the slip ring. Usually ang slip ring ginagamit siya sa AC motors. But this one for lang ini siya, class, for presentation or illustration. Actually, the actual DC generator uses katong naapod siya commutator. Dili slip rings ang iyang ginagamit because ang slip rings use in the AC machines. Kani siya gigamit lang niya for illustration slip rings. But take note, ang slip rings uses in AC machines, uh, AC motor or yes, AC motor or AC generator. Because again, sa DC machines we use commutator. Now counterpart of the slip rings is the commutator. This one, no? Ano siya ang slip rings. Okay, questions so far? Clarifications? Right? So, none so far, class. So, let's proceed. Now, let's proceed to the DC motors. Again, DC motors are everywhere. So, usually, in a house, so sa mga small mga appliances, na dito mga generators, but in the industry or in the power plant, seldom, no, you can find the DC motors because most of the motors there are alternating current or AC motors. Okay. So, but again, a DC motor is a machine that converts electrical energy into mechanical energy by supplying a DC power. So, when you say DC power, it is voltage and current. So, what's the formula of power? So, power is equals to voltage times current. So, pag when you say power, not siya voltage din, napod siya current. Alright, so accordingly, an advantage of DC motors is that it is easy to control their speed in a wide diapason. Anyway, dali ra siya class, i-control ang speed sa DC motor. It is because lang siya, you just use resistor or sa pa, resistor lang usually kay mga DC motor, makontrol na nimo ang speed ana using resistor. Unlike sa AC motor, so lisod i-control ang iyahang speed, no? Right? So sa kuan sa AC single phase motor, so sindam kay ka makakita ga speed controller. So but sa DC motor, so dali lang siya. Baka gamitan lang nimo siya o ano resistor or mga ka primary resistance or mga coil, no? Makontrol na nimo ang speed sa DC motor, unlike sa kuan sa AC motor class. Mas difficult siya i-control ang speed because you will in controlling the speed of the AC motor, so kailangan niya i-control ang frequency. Frequency, you know, frequency is cycles per seconds. Unlike sa DC motor, ang pag-control sa iya dali lang. I-series na nimo ang resistor or coil, makontrol na nimo ang speed. That's the basic difference or advantage of DC motors over AC motor. But of course, no, most of the industry nowadays are using AC motors. Again, seldom na lang nagagamit of DC motors. Mga automobiles na lang, mga portable na mga machines ang nagagamit ng DC motors. Questions, class? Clarifications? I hope that you understand the, uh, the topic about the DC motor. Okay? Question so far? Clarification? None? Sige.
None, sir. Okay naman, sir.
Now, moving forward, so this is the construction of DC machine. So, because we are still on the online class. Actually, kani sa actual, marag, klaro naman no, ang iyahang illustration, no? Cutaway view of a DC motor, and this one is stator with poles visible. So, this one, kaning Nike class, mo na siya ang stator, no? Or sa stator, ano siya ang housing kaning bakal or motor house. Then we have here the field winding. Field winding consists of coils. And there is a cutaway view. Kani siya, this one is the rotor. Again, the rotor is ang tawag sa rotor in DC motor is the armature. And the armature consists of also of the magnetic wire. So this one, this copper wire or magnetic wire, in DC motor, both the stator and the rotor has magnetic wires. Unlike in the AC motor, no, wala siya yung magnetic wire. Na dito sa iya is katong uh, square type na copper, no? Dili siya magnetic wire. And then ang sa AC motor laminated siya. Then sa DC motor, ano siya class na siya ay nasa spring para sa brass, no? Ano siya ang magtulak sa brass, then brass holder, and of course na siya ay brass. It's because ang armature sa DC motor is consists of commutator. So sa AC motor has no commutator. Take note of the basic difference, no, of AC motor and DC motor. So again, ang tawag sa rotor sa DC motor is armature. So armature consists of magnetic coil, the windings, then we have the spring, the brass holder, brass. So ang brass niya is graphite. Okay? So this one is the one of the examples of the construction of a DC machine because there are so many uh, types, there are so many forms, there's so many shapes of uh, DC motors. So this one is an example lang, one of the examples of a DC motor. Questions so far, class? Clarifications? I hope na you can now distinguish because, di ba, concurrent sabay ang pag-offer sa AC motor and DC motor. I hope you can now distinguish the difference between the AC motor and the DC motor. Okay? Questions so far? Clarifications? So, if none, so let's continue. Again, kani, this one is, kuan yun ha, focus lang siya sa rotor of a DC motor. So, rotor of a DC motor again is called armature. So, ang gini siya ang cutaway or baga sa tawag ani na view na excluded view no of the um, armature. So, this one is the commutator. So, ang commutator na po siya copper, no? Siya copper segment. Then, nasa insulation in between the copper plus. Ha? Have you seen the armature class? Kinsa na yung nakakita sa inyo of armature? Wala pa. Eh, di ba di? So, wala pa yung nakakita og armature in actual. Basically, mao na gid ni siya ang forma sa armature class. Uh, I'd like to uh, show this one para makita gid ninyo no masabtan ninyo unsa gid ang mga parts sa armature. Okay? So ang armature, both ends of the shafting sa tumoy-tumoy sa yaha na siya bearings, no, of course. Mga motors na agad na siya mga bearing. Ball bearings ang both ends. And this one is the coil. Then we have iron core. No? The iron core plus even sa mga transformer na yung mga iron core, it's because uh, dito siya mag-induce ang magnetic field. Gikan sa magnetic coil, iya siyang i-add to sa iron core. Ano siya induction plus induce niya ang magnetic field sa core. Then this core mag-produce na siya og magnet. Then it will oppose sa magnetic field food sa stator. Ano siya i-push niya para motuyok ang motor. Okay? Ano siya repulsion. Usually ang mga DC motors uh, operates on the principles of repulsion. It will repel the magnets. Yang itulak ang magnets, di ba? If you will observe, I mean, if you have experiment before, unlike pole sa magnet, the north pole and the south pole will repel each other. So, in that sense, na siya yung force. Itulak niya. Okay. But sa AC motor, it operates on the principle of attraction. Like po ang sa AC motor. Sa DC motor, wala siya i-repel niya, itulak niya ang kuan. Ang sa tawag ani pag unlike pole mag-repel siya din na siya force mag-create din. Tulak niya ang kaning armature para matuyok siya. Okay? Basically that's the principle sa one class DC motor. Okay. Question so far? So none. Uh, yes, we have coil commutator interconnection. So, kani siyang class sa copper segment sa commutator, i-connect nimo sa kaning coil commutator interconnection. Okay? Then padulong siya diri sa ayan coil. So, sa coil. Okay? Then again, na insulation. Okay, if there's no insulation between segments, ano siya segments? When you say segments, ano siya copper segment class. If there is no insulator in between this copper segments, then it will become short circuit. Then, what's the effect pag mag-short circuit? Of course, the motor mag mag-turn lang gyapon ang motor pero hinay siya. And then ang effect pod ana is masunog pod ang coil. It will burn the coil, magnetic coil here in the armature. Okay? So this is the exploded view, or these are the parts of the armature. So the armature is the rotor of DC motor. Okay? So this one is the rotating part of the direct current motor. Of course, ingani ang ano class ang forma sa iyang carbon process. Okay. Usually ang madaot sa mga ano class sa mga DC motor are carbon process. Okay. Eh mahilis mong good ni siya. There are some DC motors also are disposable. Kani siya, kanina mga design ng mga motors are repairable. I mean, pwede siya i-repair. Pwede siya i-service. Serviceable rather, repairable. Nag-word ako term na ko. Kay repair man ko, repairable. Actually, the term is serviceable. So, pwede siya ano, ayun. Una ang ah, trabaho sa mga auto electrician. But there are some DC motors, as I've mentioned, are disposable type. Once nga mahilis na ang brass, labay na siya. Kay disposable ang type. In the sense, ang pagka-design ng good niya classes, kuan siya, wala siya naka-bolt, no? Naka-rivets ang iyahang bolt. So, di na nimo siya pwede ayuhon. Okay. Question so far? So, none so far. So, let's continue. So, again, this one is the schematic. Schematic diagram. Ganesha class is pictorial diagram. So take note of the difference of pictorial diagram and schematic. We say pictorial diagram from the word picture, pictorial. So actual picture. This one is pictorial diagram. And this one is the schematic diagram. So, muna ang ano class kasagaran sa ato sa electrical. We usually use the schematic diagram and the pictorial diagram. Napatong mga block diagram. So, sendam kahit na nagagamit because block diagram, di ba, consists of mga blocks. It's usually used in the computer or electronics. But sa electrical, we are using pictorial or schematic diagram. So, this one is schematic diagram. Okay. Schematic in the sense it's using symbols. But also, basta ang ano lang ninyo, timanan nyo sa schematic diagrams using schematic symbols. Right? So, armature. Okay. So, more lobes of wire has a higher rectifier voltage. So, di ba the current and the ano class, the magnetic field is directly proportional to each other. Okay. Also with the lobes or turns, number of turns of wire. They are directly proportional to each other. Pag daghan ang number of turns, mas taas ang current and mas taas ang magnetic field. Okay? So, loops are generally placed in slots of iron core. Dere siya, this one. So, dere i-won or i-wine ang magnetic wire. So, the iron acts as a magnetic conductor by providing a low reluctance path for magnetic lines of flux to increase the inductance of the loops and provide a higher induced voltage. Okay? So, again, directly proportional, take note directly proportional the current and the voltage. And also the number of turns. The more the number of turns in the in the armature or even in the stator in the field winding, the more ang current or the more ang magnetic field or magnetic flux ayan motors. Okay? So, the entire assembly of an iron core, commutator, and winding is called the armature. So, ano siya akong i-mention kanina. The windings of armatures are connected in different ways depending on the requirements of the machine. Okay? So, later, I will show you the different winding connections. of the armature. Oh yes, this one, armature windings. We have the lap one armatures. So lap one or lap winding. Okay. So take note of the kuan class appearance of the lap winding na armatures. Yung ano siya, lap winding. Okay. Lap one armatures are used in machines designed for low voltage and high current. No? Uh, Low voltage and high current. Armatures are constructed with large wire because of high current. So usually, uh, mga starter motors sa engine sa automobiles uses the lap-on motors because lap-on motors has a high current. Uh, the use of starting motors kasi class is used to start the engine, di ba? Pag-click nimo sa ignition switch, then it will start the engine using the starter motor. So, ang starter motor has very high current. That's why usually design of the uh, starter motor of the automobile's engine, tanang mga automobile engines is lap-1 armatures. Ang iyahang pag pag design sa iyang armature. Okay? You still okay, class? Questions so far?
Yes po, sir.
Clarifications? Sige. So, the windings of a lap 1 armature are connected in parallel. Okay? They are just connected in parallel. Then this permits the current capacity of each winding to be added and provides a higher operating current. By the way, class, kaning kaning armature, lisod kay i-rewind o wala kay nag-rewind og armature. Mura na po siya og disposable type. So, what's the important here is you know the basic principle or armature. It's very difficult kasi pag rewind ani lisod kay pagbungkag no sa winding. It will take time. Although naagyo yung nag-rewind ani panagsa no. So, it's very impractical na mag-rewind pa ka because there are ano naman available na ready-made na paliton na lang nimo. Mag-rewind pa ka, it will take time and even mas expensive pa no? Compare sa magpalit na lang ka og ready-made na armature. Okay? It's not practical to rewind the armature because it's difficult to disassemble no this one and then kailangan pa nimo na siya initon og maayo para matanggal ang coil. Then again, it's impractical to rewind. Okay? Taas kayong oras. Then naa may baligya. No? Inapoy mga surplus po na baligyan siya. Ang ano lang class, ang sa stator winding or katong sa field winding, gini-rewind ito siya. Ato ka og automotive shop. Then auto electricians they will rewind that kasi mas dali lang man. Compare aning armature. Pero they should siya i-rewind. Hindi siya practical. Okay? So, another type of armature winding class is the wave-won armatures are used in machines designed for high voltage and low current. So, it is opposite sa kanina atong lap won na armature. Kani siya high voltage then low current. No? Itong kaganina is low voltage and high current. But this one is baliktad siya class, opposite siya. High voltage siya and low current. So their windings are connected in series. Okay. Then when the windings are connected in series, the voltage of each winding adds. But the current capacity remains the same. Di ba? Katong sa discuss nato sa principles of series and parallel. Once nakakonect ang coil or ang resistor in series, the current is the same. Di ba? You still remember? Then if it is connected in parallel, then the voltage, I mean the current will increase. It will add up the adds up the current. Naka-remember pa mo. Then, pag parallel class, take note of this because this is very basic principle. It can be applied in almost in all the devices. Uh, these principles is also apply in not only in resistors but also in mga electric motors or DC machines. If you're going to connect the resistor in parallel, no, what will happen to the voltage? So the voltage is equal, then the current will increase. But in series, again, the current remains the same or equal, but the voltage will increase or it will add up. I hope you can still remember. But do not forget that principle because it's very important principle. This type of kaning wave-wound armatures are used in small generator and hand crank migo meters. Okay? Hand crank migometers. Okay? Number of current paths C is equals to. So this one is wave-wound armatures. Okay? Questions so far? Qualifications? I will give you the PowerPoint of this class later na lang because I will make a Google. Okay. So we have also Prague one armatures. The most used in practical nowadays. Designed for use with moderate current and moderate armatures voltage. So the windings are connected in series parallel. Okay? So mura na siya og kanang pero ang compound it refers to ano klase atong sa stator winding. This one is armature winding. Take note, there are two windings in the DC motors. You have winding sa armature, that is the armature windings, and winding sa stator, field windings. Ano to siya katong kanina di ba na classification sa DC motor. We have simple, shunt, and compound. But those are in the kuan sa iyahang field winding. This one is for armature winding. Okay? Sabtan ba? Most large DC machines use frog leg one armatures. Okay, so kaganina class, di ba? Katong sa lap winding, series yan. Tama ba? Ang sa lap winding naka-series. Ay sa wave po, ay, parallel di ay. Sorry. Sa lap po, naka-parallel. Ang sa wave bone armatures naka-series. And then sa frog leg one armatures, the winding in the armature is connected in series and parallel. Why is it series and parallel? Because this one, these two coils naka-series, di ba? Kita niyo class? Naka-series siya. Kanina naka-series, naka-series, naka-series. Then, this series winding are connected in parallel. Okay? That's why it is series parallel. Frog leg one armatures. Alright? Questions so far? Clarifications? None? Are you still there? Okay pa mo?
Yes, sir.
Sige. So, after the armature windings, you have also the field windings. So, most DC machines use one electromagnets to provide the magnetic fields. If you have seen the mga motors sa mga toy bitaw, toy car, so ang iyahang stator class has no uh, field winding. Kinsay naka-open na og mga dulaan ng mga motor, di ba? Mga dulaan, mga remote controls or dials or basta na ay mga gagmay na electric, mga DC motors na siya class, no? Kinsay naka-try na og open ana or nakabungkag? Wala pa. Anybody? Wala pa naka bungkag sa mga DC motors, sa kanang mga gagmay na DC motors. No one? Sige. Sa mga gagmay na class ng mga DC motors, wala siya field winding. So ang iyaha dito is permanent magnet, no? North and South Pole. Okay? North and South Pole. But kani siya, since dagko na siya ng mga motors, ang iyahang stator consists of field windings. Dili siya permanent magnet. Okay? So, ang permanent magnet class is used only for small types of DC motors. So, this one, since dagko naman ni siya ng mga motor, DC motor rather, uh, ang iyahang stator consists of field windings. Because mas taas ang capacity or magnetic flux or magnetic field na ma-produce sa magnetic field compare sa permanent magnet. Diba? There are two kinds of magnets class, the permanent magnet and the electromagnets or well, artificial magnets. So, ang permanent magnet, from the word itself, permanent siya. So, wala siya coil. Katong black dito ang forma. But limited lang ang iyahang magnetism, no? Or magnetic flux na ma-produce. Unlike sa electromagnets, this one, field windings, makaproduce siya of mas dako, depende no, sa number of turns or sa magnetic coil. Depende sa design sa magnetic coils, ang iyang ma-produce nga magnetic flux. Okay? Nasabtan ba class? Okay ra? Questions? Clarifications? And so
Okay
far.
raman, sir.
Sige. There are two types of field windings. Again, series and shunt field. Okay? So, series, of course, naka-connect siya o series. Then shunt, naka-connect siya and para. Okay. Sige. So, series field windings. So, ano siya? Series field windings are so named because they are connected in series with the armature. Diba kaganina, sa katong illustration sa my first slide, ito, natay different types of uh, self-excited motor or machine. So, natay series, then natay shunt, then natay compound. So, series field winding are connected in series with the armature. And this one, ang tawag niya is series motor or series generator. Okay? And are made with relatively few windings, turns of very large wire, and have a very low resistance. So, purpose ani class para taas ang iyahang current because this type of motor used in the starter, no? Starter for starting sa mga machines. Ano siya? Starter motor of the automobiles, starter motors of the, di ba, kanang mga generator, kanang sa generator set makita niyo sa mga malls. So, nasa siya ay starter motor para mo start uh, generator. Tanang mga kuan class automobiles or even mga backhoe, mga equipment. So, they're using starter motors. Can you imagine kana mga ison, mga backhoe, pag wala siya ay starter motor, kaya ba nimo na tulakon? No? At kaya na, di ba? Mga backhoe, mga ison, mga chapadya, forklift, or even an automobile, car. No? So, even kanang mga motorcycles, di ba? So, it's very impractical na pag kuan na ka, magtulak-tulak pa ka. Although ang mga kuan class, ang mga motorcycle naman po check katong pang crank lang, di ba? Kasi nagka-motor niya. So, manual crank name under na siya. Then, napo check katong starter motor. You'll just press the push button, then start na. So, yung ana ka-importante class ang starter motor. And starter motor is one of the examples of the series field windings or series motor. Okay? Usually found in large horsepower machines, worn with a square or rectangular wire. Right? So, accordingly, the use of a square wire permits the windings to be laid closer together, which increases the number of turns that can be won in a particular space. Square and rectangular wire can also be made physically smaller than round wire and still contain the same surface area. Okay? So square wire contains more surface than round wire. Okay? So actually, 'di ba ang copper na siya yung mga square, then dapat siya yung round, 'di ba? Makikita mo na usually ang makita niyo magnetic wire is round with siya. But then may mga square po ang forma ng mga copper wire. So next is we have the field windings, shunt field windings. So shunt meaning nakaparallel siya. Iyahang uh, winding connected in parallel with the armature. That's why it's called shunt motor. Kanina shunt series motor, then this one we have the shunt motor. Shunt motor has higher resistance, which used to limit current flow through the field. Okay? So usually ang mga shunt or uh, parallel field windings are on the siya class. Gamiton siya like sa mga kuan siya, mga blower, no? Ay, ang namo ko yung mga blower like sa radiator sa automobiles na siya yung mga blower, then sa iyang aircon na siya blower, then type of DC motor use for that is the shunt. A shunt siya, shunt belt windings. So when a DC machine uses both series and shunt field, each pole piece will contain both windings. Okay, the windings are wound in the pole pieces in such manner that when current flows through the winding, it will produce alternate magnetic. So kani siya class combination, di ba? Na siya ay series, then ako siya ay field windings. Okay. So again, as a recap, there are three types of uh, DC motors or DC machines. DC generator, we have the series motor, the shunt motor, and the compound motor. So a compound motor is a combination of series and shunt fields. Okay, so I think this is the last slide. No? So thank you very much no, for listening. I hope na you have learned no, as a review. Diba, na-discuss na nato. I just ano lang, emphasize this topic because perhaps some of you murag na kuan pa kayo na sink in no, unsa gyud ang DC motors. So any questions guys clarification so with regard to my discussion. Okay? Questions, clarifications? None? So if there is none, so I guess stop na ako. So